In this video, we'll be talking about chop math. So it's more often than not in TouchDesigner that you have a few values that you need to do a mathematical operation on. So in this case, I have two constants. We'll have constant 1 maybe hold the value of 5, and constant 2 hold the value of 3. And I want to do an addition operation on these two numbers. So in order to do that, what I might grab is the math chop. The math chop is a very useful chop for doing this type of operation. So if I wire both of these constants to the math chop, I'm now able to use this property combine chops in order to do one of those mathematical operations on it. So in my case, I wanted to add them together to get 8. However, there's a few other operations here that can be useful for us: subtract, multiply, divide, and average. A bunch of these are useful both in the single channel operations, but also if we had a multi-channel operation. So let's say we have a constant that has maybe 2 channels on it, and we have let's say 12 and 3. And these 2 channels we want to do some type of mathematical operation on. We can wire that over into a math and do the same thing, but this time using the combined channels property. And the combined channels property has the exact same operations as the combined chops property. So for us, we're going to use maybe divide on this one, and you'll see that 12 divided by 3 is equal to 4. And that's a pretty common way of working with TouchDesigner. One thing to note here is that the last index here of the channel, the last index, so this one being channel 2, is going to be in the divisor slot. So TouchDesigner kind of works as you would a mathematical equation left to right. It works up to down. So that's important to know. But let's say that I had this value wasn't evenly divisible by 12, but maybe something that gives us a float number. So this 2.4 gives us an ability to show another part of the math chop, being this integer property. So let's say we don't have an evenly divisible number. We can use integer to round to an integer if we wanted that. And there's a few other rounding operations here, ceiling and floor, that are pretty useful for a bunch of different operations in Touch. Another thing to look at here is the mult and add page. So this gives you the ability to add a value after the operation, multiply the value after you've done that pre-add step, and then post-add after the multiply step. So if we pre-add, we'll add a 1 to the operation after it's been calculated, and then we get the resulting out of it. And then a post-add is the same thing. We'll add it after we do everything. So if we set both of those back down to 0, we can look at multiply. So multiply allows you to maybe negate a number by multiplying the result by a -1, or scale a number by maybe multiplying it by 10 to get an even larger number out of it. So both very useful properties and parameters to look at. So another thing to think about with math is sometimes you don't have static numbers. Those numbers are moving constantly. So in order to look at this, we might use a noise chop. And the noise chop defaults to this multi-sample chop that has kind of all these peaks and valleys. But we want a continuously changing value in our noise. So in order to do that, we're going to go over to this common page and turn time slice on, and we end up with this float value that's constantly changing. What we might want to do is limit that with an LFO. So the LFO, the value goes from -1 to +1, but if we change this to a ramp, not a ramp, a square, we get more of a digital signal of -1 to +1. But a true digital signal would be a 0 to a 1. So how can we use math to rearrange this in a different way? Well, we can drop down a math chop, And then in the range page, we can see this from range and to range. And that's basically like how we can rearrange a number from one set of values to another. So in this case, we're going from -1 to 1. If I make the from range -1 to 1 and the to range 0 to 1, now all of a sudden this is a digital signal coming out of this LFO. And that's very useful for us in this next step, where we might want to limit this noise to only appear when this value is on. And the math chop is able to do this with the multiply operation. So now the noise is only appearing when this digital signal is on or off. The last thing that I want to show you here is that math doesn't just apply to single sample chops. So if I have two patterns here, we'll use one that's a sine wave and one that's a series of ramps. So we'll maybe add 5 cycles here. We can do a math operation on these two chops as well. And what happens when you do this is that the operation happens on a per sample basis. So each one of these values will look up its opposing channel's sample and do the operation that you specify in the combined chops. So in this case, we're going to want to multiply, and we can get this kind of funky look with the ramps and the sine wave, which is super fun. So this was looking at chop math.